Okay, what's up cunts? So this video is going to be a really simple one on external game hacking. This is going to be for absolute beginners. Like if you've just started out, haven't done much game hacking, you know a little bit of programming, this is for you. This is like perfect just for straight beginners, and that's who I'm aiming for this one. It's been requested quite a bit. So let's jump into it. The aims of the video, what are you going to learn? You're going to learn what a process is. This is for Windows, by the way. This is for, yeah, if you're using anything else like Mac or Linux or some shit, fuck out of here. This is for Windows, that's the most popular. So that's what we're doing. So you're going to learn what a process is in Windows, okay? What process memory is, and then you're going to learn how to hack the processes, and then how to read and write the process memory. And what are we going to be able to do by the end? You're going to be able to hack a game's process memory, or well, like a fake game, which is what I'm going to show an example at the end of this one. Alright, so what is a process? A process is any executable file that is currently being run on the system, okay? So you can see this task manager here, it's a screenshot. You can see this game.exe here, it's an example of a game being run. So that's what a process looks like, right? You can see it in your task manager. So you can see it's an executable file. It's got .exe at the end. That's the file extension. And for it to become a process, you know, when it's run, it has to be this type of file. Alright, so what is process memory? Process memory is it's the memory that's reserved and allocated for the program at runtime. So when you run that file, that executable file, Windows, the operating system, is going to allocate a bunch of memory for that process, and it's going to get allocated in a certain structure, and I'll go into that structure. It's used to store variables, functions, and modules from the actual program for like the code and how it runs. The memory is allocated in things called pages. They're called memory pages, and basically they're just blocks of memory, right? And it's on your RAM. All this memory stuff is on your RAM, and one page is usually like 4 kilobytes long, okay? So these pages of memory are organized into sections, and this is that memory structure I was talking about just before. So you've got the stack, then you've got the heap, then you've got data, and then you've got text, and each hold different bits of data for the program. So in this example today, we're going to be reading and writing variables that are stored in a process memory, okay? And for example, this could be player health or like player ammo in a game. So in the photo here on the bottom right, you can see a bit of code, like an example program, and you can see how that's translated into the memory. So you can see the stack has the functions, the heap has like the char buffer, the array and stuff like that. The text has all the code and all that. So this is how it looks. If you visualize it, that's how the memory structure looks. Let's keep going. So attaching to a process. This is going to be the first step in our hack today. So you have to attach to a process. How do we do that? You loop through the process list. So you can see here in Task Manager, it lists all the processes. So basically, we're going to make a program that does this. It's going to get a list of all the processes currently running, and it's going to loop through that, and it's going to find our target process, which is probably going to be like a game or something. And once we find that process, we can open it in air quotes there. We open it to give our program full access to the memory of our target process. Okay, that might be a little hard to understand, but I'll go over it again. So we find our target process, and then we grant ourselves full access to that program, all the memory, so that we can play with it, do whatever we want. So we can, hack the player health, we can hack the ammo, all that. And we do this using a flag here, this flag called process_all_access, and it gives us all possible access rights for a process object. And the way we open it is by using a function called openProcess, and it takes 3 parameters here, and it returns a handle to that process. Okay. Next, reading and writing the actual memory. So how do we do it? This is really simple here. We just use 2 different functions. There's one called write process memory with a bunch of parameters here, and then we've got read process memory with a bunch of parameters, and each of them return a bool to show if it was successful or not. That's about it. So next is memory addresses. So memory addresses are basically like house addresses, but for memory. So they're stored in hexadecimal, and if you don't know what that is, it's basically a number, but it can go from 0 to 9 and has the letters A, B, C, D, E, and F. Okay, so an example is 0x in C. To show a hexadecimal, C++, C sharp, whatever. Actually, I don't know about C sharp, C++. You have to do 0x and then the hexadecimal number so that the compiler knows it's a hexadecimal value. Okay, so when we're writing our code later on, you'll see that I'll be putting 0x and then the memory address. But yeah, so an example here is 123 ABC. So you see it's got numbers 0 to 9, and it's also got some letters in there. It doesn't have to have letters, doesn't have to have numbers. Like you see, this one has just letters. This one has a mix of both. Yeah, so those are some examples. And here's a very simple example of what a visualized memory address and data looks like. So you've got the memory address here on the left, and next to it is the data value that it's referencing, right? So memory addresses are basically a way for the operating system to allocate a place, you know, like give data a house, and then it stores the house number so that it remembers where it is. Okay, that's basically my shitty explanation for it. But yeah, basically just so that you know what data is where. That's all memory addresses are for, right? So this is a simple example here, and then you've got a more advanced one over here where it's got some actual like numbers in it. So you see it's got the hexadecimal address here. So it's got the 0x in front of it to show that it's hexadecimal. And then it's got the actual number here. So it's got 0, 1, 2, 3, 4, 5, 6, whatever. And on the right here, you see the data value in binary. So address 0x0, you can just round it off to 0, it doesn't really matter. That address is storing 01001111. Okay, that's what that address is storing. If you go to the next address, 0x0 whatever 1, this address is storing this data. This address is storing this data, right? Like that's all this memory address stuff is about. It's just an address that stores data, right? It references data. All right, so well, we got that. This is the end of the slideshow. Bit of a recap here. You always want to think of your game as a process on Windows, because that's what it is. It's just a process. And when you're hacking games, you got to start thinking of the operating system. You got to start hacking the operating system to get access to the game and bypass anti-cheats and stuff like that. So sometimes it's not just a matter of hacking the actual game. You've got to hack your actual system and stuff like that. You know, like it goes a lot deeper. We're going to make a program to attach to the process. We're going to give our program all access to the process, and then we're going to read and write memory to the open process. All right, so let's get to the example here. We're going to start coding now. I've made a example program here. It's called Target. I've already built it. This is what the code is. Basically, it just has a HP. This is going to be like an example of like a game HP. So it's got HP set to 100. It's an integer, so that's going to be 4 bytes, I think. And it's just got a loop, decrements 1 to the HP, then it outputs the HP, and then it sleeps for 3 seconds. So I'll just run it right now so you guys can see what it does. So you see here, it's just outputting the HP as an example for a game. So it takes away 1 from the HP every 3 seconds, okay? So we're going to be hacking this program here. So let's start a new project. And we're going to do C++ and then Windows console application. I'm just going to call it hack tutorial. All right. Okay, so I'm going to delete all of this. We don't need any of that. I'm going to delete this line here, include pch.h. I'm going to delete that. We don't need that. I'm going to delete all the commenting. Going to keep this here. And I'm also going to delete this. You don't have to do this. This is what I do because I don't need it. And I just want to get rid of it. I'm deleting the PCH files, which is like an automatically included bullshit. Then I'm going in the project settings, I'm going C/C++, and then I'm going precompiled headers, and I'm going to precompiled header, and I'm saying not using precompiled headers, okay? So that's what I'm doing right off the bat. You don't have to do that, that's just how I'm doing this. I'll zoom in a bit so you guys can see in case you want to code along. Alright, so let's get rid of that. And what we're gonna do, yeah, okay, we'll just start coding now. Alright, so we're gonna have to include a couple files here. So include, we're gonna go windows.h, fuck. I'm having a bit of a stroke, sorry boys. Why is this, does that have to be capital or some shit? No, that's good, okay, cool. And then we go tl help 32.h, and that should be it. Alright, we're gonna need 2 global variables here. So we've got a handle, that's gonna be our handle to the process. If you remember it from what I was talking about previously, this is what we're gonna get when we open the process, okay? We're gonna get a handle to the process, and then we can read and write memory with that handle. And then we're gonna need the process ID, okay? So what's a global variable? Basically, it just means you define a variable outside of all classes, structures, functions, so that you can reference it in all classes, functions, and structures, right? That's basically what you do. So that it's just globally defined, and you can reference it anywhere you want, basically. And we're gonna have to do that. We're gonna have to reference it in a couple places here. So we're gonna start off with making a function. It's gonna return a boolean. It's going to be attach procs. This is where we attach to the process that we want, and we're going to take a argument here. It's going to be the process name, so that we can attach to whatever you want. You know, you guys can code this and then adapt it to a game maybe or something. You know, do what you want. So we're going to do process entry 32, and it's going to be called proc entry 32. Simple. All right, then we're going to go proc entry 32 dot bword size, and we're going to set that to the size of process entry 32. Awesome. So we're defining the size of the structure here so that we can populate the structure so that it knows how big it needs to be, right? All right, then we need to do, we're going to do this auto h proc snap fuck. Yeah, that one. H32 CS. Snap process. Alright. 0. Cool. Alright. So what this here is doing, what auto is, it basically just means it's automatically finding out what data type this has to be. So that I don't have to check myself and manually write it. It's just a lot easier. But what we're doing here is, maybe I should comment this actually. Alright, so this is just defining the size so we can populate it. Also, this code can be found in my nullbase, I think. You might have to go digging around for it, but I'm pretty sure this function is in nullbase. You can find that on my GitHub. But if you want this project's specific code, if you want all the code from this video, that's going to be on my Patreon, link in the description, or you can see in the bottom right hand corner there, I've got my my name on Patreon. You can just search for it if you want. Yeah, you can also get private tutoring on that. Quick ad there. Also, you get early videos. I'm going to be releasing this video, I think, a day early on Patreon, and then it'll go to everyone else. Okay, and then this line is doing, basically, I'll say it verbally, then I'll comment it. Okay, so it's getting a snapshot of all the processes. So this is getting the list of all the processes currently running on your system so that we can loop through it and then look for our target process, okay? So I'm going to comment that in now. Alright, basically, that's all it's doing. Next, I'm going to do an if statement here. Alright, so we're checking, we're doing a bit of an error check here. Alright, so if that snapshot failed and it returned an invalid handle value, we're going to do a output and we're going to say failed to take snapshot. Processes. And we're going to do end line there and then return false. Okay, so that we know that this function failed. Otherwise, let's keep going. So we're going to do a while loop now, and while process 32 next, I think. Yep. hproc snap. Okay. So what this is doing is we're looping through the list of processes now. That's what the while loop is, okay? So while there is a next process in that list, we're going to keep looping. So let's do this. Fuck me, holy shit. We're going to output the name of the file that it's currently at. So this is going to be just so you can see all the processes that it finds. You can also use it for debugging to see if it's actually finding your target process. If not, you might have made an error or you might need to change something. But alright. Why is that an error? What? Okay, cool. Alright. It's good that I got this error. A common error that people run into when they're making hacks or following hack tutorials, especially my tutorials, is that they run into this problem here where it's incompatible, you know, conversions, whatever. It's a basic fix. I've probably got asked how to fix it like 20,000 times. Alright, you got to go project here, project properties, then you go general, and then down here at character set, you just change it from Unicode to multi-byte. Okay, that's what you got to do, and that should get rid of the error. That's all you got to do. Alright, so let's output that we finally found the process. Okay. What is it called? Process ID, that's the one. Alright, cool. No, not parent, just process ID. Fuck me. Oh, mate. I'm having a fat stroke. Alright, cool. And then end the line there. Cool. Cool. So what are we doing here? Well, we're looping through the list of processes. Then we're going to output the process that it's currently at. And then if the name of the process we're at right now matches the one we're looking for, then we found it. So we're going to output that we found the process, say the file name, the process ID, and then we're going to keep going with the code here. Then we're going to open the process now. So hproc open process all access. So that's the flag that I was talking about before. This flag is going to grant us all access to that process. Okay. We're going to return false there, and then proc entry 32 dot process ID. Not that one. This one. Cool. That should be it. Then we're going to set our variable to the process ID because we're going to need it for later on. Alright. Then if we're going to do an error check here real quick. Let's do, yeah. So up here as a global val, let's just do this here. Set this to null. Okay. So then if the open process doesn't work, this error check's gonna work. Then we're gonna output that it failed. Okay. Cool. And then after that, we're gonna have to close the handle. Do the snapshot, but we're gonna keep hproc here because we're gonna have to keep referencing it in our hack. And then return true because it worked. Okay. So down here, we're going to add a little bit more code, and this is going to be if we couldn't find the process we're looking for. So we're going to say couldn't find proc name in the process. Alright, cool. And we're going to close the handle again. So actually I'm just going to copy this line here. And then return false because it didn't work. Alright. So let's go through this function. I'll comment all this later and the code will be on Patreon. So we're doing all this, already explained that. And then we're getting a snapshot of the process list, checking if it worked. Then we're going to loop through that list. And we're going to see if we find the process we're looking for. If we do, then we're going to open that process, get all access to it, and then we close the handle to the snapshot. We return true. Otherwise, if we couldn't find it, then we return false so that we know that it didn't work. Okay, so now we're going to make some wrappers for writing process memory and reading process memory. So what a wrapper is basically just, in this case, it's going to let us call functions a lot easier and have to pass like half the parameters to it. So we're going to do a template. Okay. And then open that up. Okay, so we're making our write process memory function here, and it's going to be a wrapper so that we pass, you know, way less functions. So we pass way less parameters, and it's just going to be way easier to call. So this is the main function that we're calling, write process memory, and because it's got a lot of constant parameters, this wrapper is going to come in handy because then we don't have to pass a bunch of arguments to it. Okay, so that's basically it right there. That's the write process memory wrapper. Then we're going to do the read process memory wrapper. So it's basically the same thing, template. Then we're going to go data type, RPM. Then we're just going to need an address to read. So this address stuff I'm talking about is the memory addresses, okay? Then we're going to need a variable here, data type, RPM, buffer. Then we're going to need to call the actual function, read process memory, hproc, pvoid of the address. And then pass 0 for the last one, and then we're just gonna have to return what we read. And that's the wrapper right there. So that's the write process memory and that's read process memory, alright? So let's start hacking now. So let's open up that target process that we got here. Okay. Now what I'm gonna do to get the memory address, I'm gonna use Cheat Engine. Cheat Engine is an awesome program. You can use it to hack games. A lot of people use it to hack games, and it's I use it personally to hack games. It's just really easy to use and it's very versatile. So we're gonna attach to this target process here with Cheat Engine. So I'm gonna go in the top left here. Then we're gonna click on target exe, and in here I'm gonna type the value. For the value, I'm gonna type the number it's outputting here, which is the fake HP or health, in a game. But I'm gonna set it to exact value here, and I'm gonna search for 4 bytes because this is an integer, and integers are basically 4 bytes in memory. Okay, so that's 4 bytes is integer for this. You can also search for floats, doubles, strings, whatever. It depends on what you're looking for. But right now we're looking for an integer. I'm gonna wait till it refreshes there. I'm gonna go 76 here. Alright. So we scan, comes up with 3 results here. I can already tell that this is the one we're looking for because these two aren't updating like this, but this one is updating. So this is the one we're looking for. These two might just be random values. You'll always get this in games, because there's a bunch of memory, Alright, so if we look at this value, we could test it by just setting the value. Let's just set it to 100 again. Let's see if it hacks it. Yeah, so you can see it went back to 99 here. So this is the right value, this is what we want to do. But we don't want to use Cheat Engine to hack the game, we want to make our own program, right? So basically we're going to do what Cheat Engine does. So you can see here the address, this is the memory address. So this memory address is storing this value, okay? And it's 4 bytes long. Okay, so I found an error in my code. Okay, it's such a simple error, but here in this if statement here, in the attach proc function, this if statement was like this: if hproc equals null, just add another equals there. This was giving me so much trouble, but yeah, make sure there's 2 equal signs there. And now we can continue with our hack. Okay, so we found the memory address of this value. This number is going to look different for you because that address changes every time, every time you run it. So we're just going to copy that memory address, okay, and paste it in here. You see, you get an error, right? It comes up with the red line. That's because, like what I said before, you got to add 0x in front of it, and now the compiler knows it's a hexadecimal. So we're going to make a D word, okay, and we're going to call it memory address, and we're going to set it to that. So this is the memory address we want to hack, okay? We have to attach to the process first. So we want to attach to this, and it's called target.exe. You can change this to whatever you want. This could be the game you're hacking, csgo.exe, whatever. And we're gonna have to typecast it. That basically just means this here, we do brackets and then a data type that you want. What that basically does is it forces the variable here next to it to be converted to that data type, okay? There's some things that you can't convert, but it's, you can do it with like quite a few data types. Okay, so once we've attached, I'm going to do a while loop here. We're going to do while true, which basically that just means forever, like keep looping forever. And all we have to do is we're just going to write an integer. We're going to make it 100, and we want to write the memory address. Okay, that should be it. Attach the process, then write it. Yeah, okay. So let's try that out. Okay. Alright, let's see. Okay, let's see if it, yeah, there we go. So you can see it outputted the list of all the processes that it found, all the executable files that are running, and then it found our target with gave us the process ID as well. You can see here in the output, this is the target process. The HP in this very good game has been hacked, and now it's constantly being written to 100, but it's showing as 99 because the program's minusing 1 each time. So if you wanted it to be, you know, fully 100, you could just do this. Just do 101, and that would keep it at 100. I'll just do that because I've got OCD. So okay, cool. So there you go. So now it's 100. But yeah, so you can apply this to any game you want, any program you want. You know, as long as it, you know, you could bypass anti-cheats and stuff like that. But yeah, so this was just a really basic tutorial for like absolute beginners, just to get a grasp on memory, hacking, reading, writing, all that stuff, memory addresses especially. So yeah, if you want to see maybe something else similar to this, something like, you know, more beginner stuff, let me know. If you have any problems, join my Discord server, link in description. You can add me on there, you can message me, there's a lot of cool people on my server that will help you. Bunch of sick cunts, they like know way more than me. But yeah, you can get a bunch of help on there if you have any questions, if you just want to talk, do that. Yeah, thanks for watching. If you want the source code for all of this, it's going to be on my Patreon, link in the description. This video is going out early as well. You get early videos on my Patreon. You can also get private tutoring on game hacking, programming, whatever you want. Yeah, thanks for watching. See you guys later.